back to another Amazon live stream. And today we're going to be going over AWS cloud computing. So let me share my screen and then we can get started. Okay, so welcome to cloud computing. Day one starts off by talking about what cloud computing is. So the definition is the on-demand delivery of compute power, database storage, applications, and other IT resources through a cloud services platform via the internet with pay-as-you-go pricing. AWS itself started cloud computing in 2006, where they sold IT infrastructure services to businesses as web services. And it provides a simple way to access servers, storage, databases, and a broad set of application services over the internet. A cloud services platform like AWS owns and maintains the network connected hardware which is required for these services, while you both provision and use what you need. It helps to build and run applications, and cloud can also be used for the deployment and management of these applications. It's available to hundreds of thousands of customers across 190 countries, and it has powerful resources at a low operational cost. Its classically provisioning services is like a Goldilocks system, and with AWS, you can elastically scale up or down. Cloud benefits. So the ability to deliver innovative new feature to the market quicker is one of the benefits. It's also focused on adding differentiated values, and it makes new ideas feasible that were once out of reach. Here, experimentation becomes fast and low risk, and it can adjust to fit any workload. Also, it can help businesses serve their customers globally without the need for expensive time-consuming expansion. And it can also deploy web services using tools and languages like Chef, Visual Studio, PHP, Java, Python, etc. It connects to personal infrastructure by private dedicated connectivity. Continuing the benefits, so you trade the capital expense for variable expense. You'll pay for what you consume and you pay only when you're consuming it. The next benefit is benefiting from massive economies of scale. So there's a lower variable cost, you can achieve higher economies of scale, and it leads to lower prices. Also, you can stop guessing about capacity. You can access as much or as little as needed, and you can scale up or down when necessary within a few minutes' notice. For increasing speed and agility, it reduces the time it takes to make resources available. So this causes a large increase in agility because of the cost and time to experiment being extraordinarily lower. You can stop spending money and maintaining data centers, so you can focus on your own customers. And also, you can go global in minutes. You can deploy your application in multiple regions around the world really quickly in just a few simple steps. And this means that you can provide lower latency, which is delay before the transfer of data, and a better experiences for your customers at a much smaller cost. TCO. So TCO reduces the need to invest in large capital decisions, and it provides a pay-as-you-go model which allows you to invest in the capacity that you need to and use. These calculators are what allow you to estimate the cost and savings, and these calculators also modify assumptions that best meet your business needs. The calculator provides directional guidance on possible savings, and the tool is built on an underlying calculation model because it generates a fair assessment of value that a customer may achieve. It's important to know here that a TCO calculator result should only be used as an approximation and not the actual amount. And this is a video on cloud computing, which will be posted after the live stream has finished. So day two starts off with talking about types of cloud computing, and there are several different methods or models of cloud computing, and it allows for the different amount of control over the web services. So there are three main types: infrastructure as a service, platform as a service, and software as a service. So to start off talking about infrastructure as a service, this contains the basic building blocks for cloud IT, and it typically provides access to networking features, computers, and data storage space. It has the highest level of flexibility and management, and it's most similar to existing IT resources. It also has an instant computing infrastructure. Platform as a service removes the need for organizations to manage the underlying infrastructure, and this is usually hardware and operating systems. It allows for the focus and the deployment and the management of applications, and it helps for the business owners to be more efficient. It also disregards the human concern over resource procurement, capacity planning, software maintenance, patching, etc. And this is basically just a combination of hardware and software components. Moving on to software as a service, this provides customers with a completed product which is run and managed by the service provider. SaaS is usually referred to as end user applications, and there's no user concern about service maintenance or how the infrastructure is actually going to be managed. The only thing that you need to know is that the infrastructure is going to be available. An example of how a web-based email would be used to send, and this is a video on IaaS and SaaS. So day 3 starts off by talking about how you could deploy the cloud infrastructure easily. So it's important to keep in mind that there are 4 key areas to make deploying the cloud infrastructure easy. Highly trusted global infrastructure, providing broad compatibility with all popular workloads, fast and secure private networking, and the tools to control access to all the cloud resources. So highly trusted global infrastructure. This is designed for high security and availability needs of the large enterprises. It offers capabilities that restrict unauthorized access or usage without sacrificing flexibility, and it acts as a backup for all features, providing broad compatibility with popular workloads. So this can spin up virtual servers, hard drives, databases, networks, and more. And you can easily set up those. For fast and secure private networking, you can provision a private sector networking, and the cloud environment becomes an extension of your on-premises environment. Here you use the data when it moves from your environment to the cloud, and a network connection from your existing centers to AWS. This ultimately gives you predictable because it bypasses the cloud resources. So here you and this gives a greater flexibility to rapidly create new apps, lower costs for existing apps, and to also from the security of AWS. Or they're migrating from a low-level infrastructure and they can services which provide a detachment from management, architecting, and scaling. Hybrid is a way to connect infrastructure and application deployment is to extend and grow an organization's infrastructure into the cloud while connecting the cloud resources to the internal system. And this runs applications in both the cloud and on-premise, and ultimately you can access AWS wherever necessary. On-premise. So this is also referred to as the private cloud, and it uses virtualization and resource management. On-premise development leads to the inability to receive management and virtual cloud for premise. Infrastructure installs safeguards in order to protect privacy. It manages dozens of sorry about that. And it saves money at the same time. It can also scale security with your AWS usage, and it maintains the security regardless of the cloud size. And this is a video on AWS security. So moving on to AWS Analytics Services. These are a set of services that handle every step of the analytics process. And the services are powerful, flexible, but also simple to use because they enable organizations to put their unorganized data to work efficiently. Some example services include Elasticsearch, Amazon Kinesis, Amazon Redshift, and Amazon Athena. Search and analytics engine, which is used to absorb, buffer, and process streaming data to find insights promptly. And Redshift can ask questions and combine exabytes of organized and disorganized data across your data warehouse, operational database, and data lake, using a language called SQL or Standard Query Language. And Amazon Athena is an interactive question service which makes it simple to analyze data in Amazon Edge 3 by using SQL. AWS Compute Services are AWS is basically just how AWS offers multiple services that can deploy, run, and scale applications as virtual servers, containers, or code. Examples for this include Amazon EC2, Lightsail, or Elastic Container Service, or ECS. EC2 obtains service quickly and inexpensively. Lightsail creates a virtual private server on AWS, and ECS runs on Docker containers, including software that are in standard units used as containers. And these containers package everything a software needs to run, including libraries, system tools, code, and even runtime. AWS database services. So these are necessary databases for applications like managed relational, non-relational, data warehouse, in-memory data store, and graph databases. There are two types on this slide: DynamoDB and Amazon Relational Database Service. So DB is a fast and flexible database service for any workload, and you only pay for what you utilize. The key value database that delivers nearly instantaneous single-digit performance at any scale is this one, and it's built to handle internet applications. It's a fully managed service, and it handles more than a trillion requests per day. And Amazon Relational Database Service, or RDS, is a service with 6 well-known database engines, and it can be set up, operated, and scaled in a few steps. In the corner of the slide, you can see a video which goes into more detail about understanding Amazon Relational Database Services. Day 5 starts off by talking about AWS developer tools. So these contain code and automatically create, evaluate, and deploy applications. They're a set of services that quickly and carefully deliver software. The services store and hold control of your application source code, and they're used for constant integration, continuous delivery, infrastructure as a code, and monitoring. AWS Code Pipeline. So this can create an end-to-end software release workflow using services. It's continuous delivery service that automates release of pipelines in order to have both a fast and reliable application, as well as infrastructure updates. And here you can effectively and efficiently deliver features and updates. AWS Cloud Development Kit. So this is an open software development structure to define your cloud application resources using known programming languages. And this basically supplies cloud applications. Supplying cloud applications, they can be challenging process because they require you to perform manual actions, write custom scripts, maintain templates, or learn domain from specific languages. And AWS CDK utilizes familiarity and expressive power of programming language in order to model your applications. AWS Code Deploy is the tool which installs applications to update servers, and it basically just lowers the workload on developers and quickens the releases of new products and features. Code Deploy makes it simple for users to rapidly release new features, helps dodge the downtime during the application development, and helps deal with the complexity of updating the applications. Positives of this include automated deployments, minimized downtime, centralized control, and also just being easy to adopt. AWS management tools allow you to provision, monitor, and set forth your cloud environment. You can maintain stable control without restricting your development speed. AWS CloudWatch is a service which was built for developers, system operators, site reliability engineers, and IT managers. So CloudWatch provided information and insights in order to monitor your applications, understand and respond to system-wide performance changes, optimize resource utilization, and get an allied view of operational health. It gathers the monitoring and operational data in the form of logs, metrics, and events, providing you with a linked view of AWS resources, applications, and services that run on AWS and on-premises servers. CloudFormation provides a common language to supply important assets in the cloud. Versions can be automated to be sent over and over again, and models infrastructure using a simple text file. AWS Systems Manager allows for the full control of the structure of AWS. They automate for the tasks needed for the smooth operations. They help for the guarantee of the security and compliance, and they also detect problems quickly. And now networking and content delivery services. So these allow you to isolate your cloud infrastructure, scale the request handling capacity, and also connect physical network to a private virtual network. The networking here products would together meet the requirements, and Elastic Load Balancing coordinates with Amazon Virtual Private Cloud to give networking and security features. It distributes the application traffic among different services, and it handles traffic in one or more availability zones or data centers. It also improves the scalability or adjustability of your applications. And storage services are reliable, secure, and adjustable locations for your data. AWS offers a wide variety of cloud storage services in order to both support the application and archival compliance requirements. Archival requirements are the dates when things can be archived, so they're stored away and hard to get back. And one can choose from the different options to build the base of your cloud storage management solution. In AWS, the different types of storage services include things like object storage, file storage, block storage, backup, data transfer, and edge computing and storage. And this is a video on the introduction to AWS.
Hi.
That's it for cloud computing. Thank you for watching, and we hope to see you in the next slideshow. Thank you.